Today we are going to discuss about structural and behavior description. Last class we studied that we can perform a number of different design tasks at different levels of abstraction, such as creating requirements and specification, architecting the system, designing the code, and designing tests, etc. So it is often helpful to conceptualize this task in a diagram. So there is a visualized language that can be used to capture all these design tasks, that is known as Unified Modeling Language or UML. UML was designed to be useful at many levels of abstraction in the design process. It is also useful because it encourages design by successive refinement and progressively adding details to the design. We know that UML is an object-oriented modeling language. In this uh, object-oriented design mainly emphasizes two concepts. One is, it encourages the design to be described as a number of interacting objects. That is, it encourages the design to be described as a number of interacting objects. Objects are interacted each other, and that will be specified in the design. Then second point, at least some of this object will correspond to a real pieces of software or hardware in the system. We can also use a UML to model the outside world that interacts with our system. We know that in an object-oriented system, the most important thing is object. Next, we will discuss about structural description. By this structural description, we mean the basic components of the system. In this, uh, uh, we are discussing about the basic components of the system, and the principal components of an object-oriented design. We know that it is a object. So object include a set of attributes, and these attributes defines its internal state. When implemented in a programming language, then these attributes usually become variables or constants held in a data structure. So when we try to implement a uh, object into a programming language, then this attribute means is when we are using a constant or a variable uh, corresponding to that data structure, that will be the attributes of that object. Then we can also specify the type of the attributes. So here that is the type, which type we are using, that will be also included into the object. Then next one is class. Class defines the attributes that an object may have, and also it defines the operation that determine how the objects interact with the rest of the world. So next terms that is used in object oriented language is a class. So class is a form of type definition. All objects derived from the same class have the same characteristics, although their attributes may have different values. So a class is defined as the attributes that an object may have, and it also defines the operation. So a class has its attributes and operation. Using this operation, we can determine how the object interact the rest of the world. In a programming language, the operation would become a piece of code used to manipulate the object. This is the class representation in a UML notation. In this, the text in the here the text in the folder corner page icon is a note. So it does not correspond to an object in the system. It only serves as a command. The attribute is an array of pixels that hold the content of the display. The object is identified in two ways. It has a unique name and it is a member of a class. The name is underlined to show that this is a description of an object and it is not a class.